Dear student, today we will discuss about the graphing of data. Let's see.
Data can be graphically represented in 4 ways, using bar graphs, histograms of uniform width, histograms of varying widths, and frequency polygons. A bar graph is a visual representation of data using rectangular bars of uniform width. The bars can be plotted vertically or horizontally. It helps in comparing the quantity of the categories of a given variable. One axis of the chart shows the categories being compared, while the other axis represents their respective quantities. Tap the button to understand this better with an example. Make a bar graph to depict this data. Make a bar graph to depict this data. Make a bar graph to depict this data. Choose the correct option. Choose the correct option. A histogram is like a bar graph, but used for continuous class intervals. Unlike a bar graph, the areas of rectangles in a histogram are equal to the corresponding frequencies. Consider the following table showing the weights of 32 students in a class. To draw a histogram for these continuous class intervals, we will first represent the weights on the x-axis with the scale as 1 unit equal to 5 kilograms. Now, to represent the number of students or frequency on the y-axis, we can choose the scale as 1 unit equal to 2 students. Drawing the rectangular bars of width equal to the class size and lengths equal to the frequencies of the corresponding, we will get the required histogram. Let us now learn to draw histograms with varying width, using the following data showing the marks of 32 students in a science test. You may notice the varying class size in the table. The class size of the first interval is 20. the class size of the last interval is 40 and the class size of the rest of the intervals is 10. Since the size of the majority of the classes is 10, we set 10 as 1 unit of the x-axis. The first and the last intervals would then be spread over 2 and 4 units respectively. Now, to represent the number of students or frequency on the y-axis, we can choose the scale as 1 unit equal to 2 students. To ensure that the areas of the rectangles are equal to the frequency, we will have to proportionately reduce the length of the rectangles, where the class size is spread over more than 1 unit. This means the first and the last class intervals will have reduced lengths. Note that the lengths for other class intervals all match the frequency. Drawing the rectangular bars of width equal to the varying class size and lengths as calculated, we will get the required histogram. A frequency polygon is another way of representing data and its frequencies. To make a frequency polygon, the midpoints of the tops of adjacent rectangular bars of a histogram are joined. The area of a frequency polygon is always equal to the area of the histogram or the total frequency of data. So, to make the area of the frequency polygon equal to the histogram, we need to create 2 zero frequency points in the intervals before and after the histogram. Here, A, B, C, D, E, F, G, H is an example of a frequency polygon. Frequency polygons can also be drawn without using histograms. This can be done by joining the midpoints of the class intervals, also known as class marks. Class marks can be found by dividing the sum of the upper and lower limit by 2. Let us now make a frequency polygon for the given data showing the time taken by 52 runners to run 10 kilometers. To plot the frequency polygon, we will first calculate the class marks for each class interval, which, as we saw earlier, is calculated as half the sum of the upper and lower limits. Let's plot the time taken along the x-axis and number of runners along the y-axis. We then plot and join points B, 32,2, C, 36,5, D, 40,8, E, 44,10, F, 48,11, G, 52,6, H, 56,9, and I, 60,1. We next plot the class mark for the class, just below the lowest class, 30 to 34, with 0 frequency. That is, class 26 to 30 is marked as A, 28,0. We also must plot the class mark of the class 62 to 66, which is immediately after the highest class 58 to 62 with 0 frequency. That is J, 64,0.
Plot a frequency polygon for this data without constructing a histogram. Plot a frequency polygon for this data without constructing a histogram. Plot a double frequency polygon for this data without constructing a histogram. Plot a double frequency polygon for this data without constructing a histogram.
Choose the correct option. Choose the correct option. Choose the correct option. Let's summarize what we have learned in this topic.